So you guys are able to do the derivatives quite well, but now we're going to look at what happens if you weren't given the equation. Because you've got all these rules for changing the derivatives from an equation. What if you were just given the original graph? What are some of the strategies that we can use to see what the graph of the new derivative would be based on just seeing the graph of the old derivative? And the way that we're going to look at this is we're actually going to start with 4 and 5, because they're very typical examples, and something that comes up with the derivative. First of all, wherever you have a maximum and a minimum, so I'm going to label those on graph number 4 with blue dots. Wherever I have a maximum or a minimum on my graph, if I drew a tangent line there, what would the slope be? 0. And if the slope, if that's what your derivative is finding the slope at those points, I'm going to draw my derivative in green here. I know at this point my derivative is equal to 0. I know at this point my derivative is equal to 0. And I know at this point my derivative is equal to 0. Does that make sense? Now we're going to look in between those and look at the derivatives in between those x-intercepts of my derivative graph. So in between the first minimum here and the second maximum, if I looked at just this section, I'll draw it in blue here, this section of the graph, if I drew any tangent on that section, does it make sense that any tangent in that section is going to have a positive slope? So when I draw in between those two x-intercepts, it has to look like that. It has to be above the x-axis. Now if I look at the next section between the maximum and the minimum, what are the slopes of all those tangents going to be? They're all going to be negative. So I know between here, it's going to look like that. I don't know how high it goes or how low it goes in between those points, but for right now I'm just trying to get an idea of what the sketch looks like. Then the only parts that we haven't done are on the outsides. So if we do before this first minimum, can you see that all the slopes are negative? So this is going to go down like this. And after this last minimum, all those slopes are going to be positive. It's going to go up like that. So part of what you're going to do is you're going to look for where are the points where my derivative is equal to 0. If I have any maximums or minimums, I'll make those zeros. So if we look on our next graph, number 5 here, can you see that you have a maximum here, a minimum here? At both of those points, our slopes are going to equal 0, the slopes of our tangents. So we can go down, corresponding green point right there, corresponding point right there. If we looked in between those two x-intercepts of our derivative graph, every tangent between that maximum and that minimum is going to be negative. So we know it's going to look like that. Every point before the first maximum has positive slopes. And every point after the minimum has positive slopes. And this is the part that sometimes gets confusing, because when we look here, we'll often say, oh, to the left, I'm going downhill. But I'm moving from right to left. And I might be thinking it has a negative slope. So sometimes it's actually helpful to draw a tangent on there and think about what is the slope of that tangent line. Is that a positive number or is that a negative number? And then you'll say, oh, it is positive. Another thing that's going to help you with these questions where you have a graph and are asked to graph a derivative. So in question number 4, looking at this graph and its shape, can you recognize it that it's an x to the 4 graph? And if I do the derivative of an x to the 4 graph, I'm going to have to get an x to the 3 graph, a cubic. Same thing here. Can you see that the original graph on this one was an x cubed graph? So if I do the derivative of an x cubed graph, my next graph should be an x squared graph. So those are some of the things. Can you see that this one's a line, y equals mx plus b? So if you had a line, y equals mx plus b, whenever you do the derivative, you're just going to get m. What does the slope of this line look like? It is. Looks like it goes down 2 over 2. Does it look like it has a slope of -1? So the derivative graph of this one, its slope is always -1. So those are some of the things of the basic ones. There's some more complicated ones like the absolute value graph there. You're going to have to think about those. But those are some of the ideas that you can use when you're given one graph to find the derivative graph. The matching ones are on the back. And then you can solve the puzzle.